Greetings to all of you. Welcome to the third video of Array Mastery series of Code Sprint. Now we'll continue with the topic prefix sum. We will understand the concept of the prefix sum and we will apply it to some problems that will be covered in this video. This is very important video if you are looking for prefix sum from beginner level to some level that you are able to solve questions on your own on LeetCode, Geeks for Geeks, or any platform that you like. This is just a starting point, but it covers many video and many patterns. Let's dive into it. So first we have to understand what is prefix. Prefix sum is pre-compute running totals, so range queries become instant. This is the definition which is written on this PPT. Let me walk you through this example. What does it say? Here the sum is 3. Now 3 plus 1 is equal to 4. 4 plus 4 is equal to 8. 8 plus 1 is equal to, uh, here is 3. 3 plus 1 is equal to 4. 4 plus 4 is equal to 8. 8 plus 1 is equal to 9. 9 plus 5 is equal to 14. 14 plus 9 is equal to 23. 23 plus 2 is equal to 25. Then plus 6 is equal to 31, which is the total sum of the array. So, what this signifies, what this generally say, what is this pattern? We have this array. Let me have my laser. We have this array. We have this prefix. So, what this pattern says? This pattern says that our prefix array is nothing but the sum of previous element of the prefix array, which is I minus 1, plus current element of the array, which is A of I. So this is the general term of the prefix array. Now here I should be greater than or equal to 1. As you can see that if I want to calculate the prefix sum of this one index, then I have to put 1 here. Then what happens that P of 1 is equal to P of I minus 1, which is 0. The P of 0, what is P of 0 here? It is 3. It is already written from the array. And we have to add the current element of the array, which is 1. So 3 plus 1, which is 4. So that's how we calculate, or you can say pre-populate the prefix array. Now we will talk about this, which says the sum of any range. Suppose you have given the range that you have to calculate the sum of numbers from second index to the fourth index. From second index to fourth index, these are the elements 4, 1, 5. So, but we do not have to iterate this array because we already pre-populated the prefix array. So what we will do, we will take the last element of the range, which is on the most right side, and previous element of the first element. This is first element, and the previous element of the first element should be subtracted from it. So when we take this and this, we'll have 14 minus 4, 10. 10 is a sum of this range. This is the formula. I also break it down. Sum is equal to prefix of R minus prefix of L minus 1, which is the element behind the first element in the range. So this is all about the prefix sum definition and its implementation in the range sum question. If you encounter such question, you can answer very easily. And now let's move next slide. So these are some pattern we are going to discuss in the upcoming slide, and we will cover this pattern now only, and you will see that how the magic of prefix sum works. That how the questions on these pattern, problem statements on these patterns are solved using this prefix sum. That how you can identify that prefix sum should be applied. So these are some signals that repeated range queries that you have to count with associative and invertible operations like sums or product, subarray language type problems, static data. So we will cover this in. Now this is the core template. I have discussed you this formula before, but here I put I and here I put I minus 1, which is obviously equivalent. If I put I here and I minus 1 here, then it's also fine. It's same. So let's move to the slide. These are all the things which we will cover. These are the patterns of the questions. First is basics, range sum, prefix sum plus hash map, prefix unique modulo, difference array. Okay. So by reading this slide, you will not understand what this slide meant. You will understand when you will do some questions. That like this is the question I am gonna do with you. Very very famous question. Count average with sum is equal to k. We will do it. So we will have 10 questions in this video. We're covering the 5 core patterns which are written here. Fundamentals I have covered with you. Uh, Prefix sum plus hash map, modulo, parity, multidimensional, difference array. We will cover all these patterns. These are the only patterns which I covered in most interviews and which are present in most famous platforms of coding like LeetCode and Geeks for Geeks. So let's do this. First problem of the prefix sum topic that we have covered the concepts. The problem from the LeetCode 724, you can check it out on the LeetCode first and then you can come here, try with me. Problems is given an array of integers, such as the pivot of this pivot index. Index is sum of all numbers. To the left is equal to sum of all numbers to the right. So the index on the left when it's okay, then the left sum is 0 because there are no elements. That's fine. It also applies to left. So you find that it is the most leftmost pivot element. You have to find the index where the sum of the left side and right side is same. So you see this arrow. There is one, two, you see this arrow. There is one. This is the index. This is the index where this is three sum and this is also a three sum of this element. This is the either one or two is a pivot fix. We have to cover this type of case also. It's a the length of the array is even. Let me example 1736. The length of pivot index is 3, which is 0, 1, 2 to 6 are at 6. Then 6 is not included. 1 plus 7 plus 3 is 11 and 5 plus 6 5 of 6 is 3. So I don't think this example won't be valid. We have to have a odd number there. Right in this situation. If we have even number with the pivot index finding the pivot index, we have to return the minus one. We have to take care of that. If there is even length. Correct. Now we have covered the prefix sum topic. So here also we have to find the sum of left and right. First of all, can we make a prefix sum array of first example? So here is 1, 1 plus 7 is 10. Let me erase it so that you can look at this. Kindly before my mind erase it. 1 plus 7 is equal to 8. So 1 plus 7 is equal to 8. 8 plus 3 is equal to 11. 11 plus 6 is equal to 7. 17 plus 5 is equal to 52. And 22 plus 6, which is the end element, is 20. This is the prefix sum. First of all, we have to first we are starting from the first segment. So here, the left you have to have two variables, which is left sum and right sum to track the sum left and right. So all and a pointer and the pointer basically. So first, so when we are at the zero index, the left sum is 0 and the right sum is 1. Left sum is 0 and right sum is 1. I'm at the 0. Okay, sorry, not 1, it's 8. 8. Just a moment. I think I'm getting something. If I'm at this index, if I am at first index, I don't have anything near the left. So left is 0, that's fine. But I have this in the right. It is nothing but the total of the array minus the current element. So right sum is nothing, not the next element, but total sum, which is the last element of prefix sum array, minus the current, minus a of I, the right sum. And we will move by applying this formula. And wherever we find the LS is equal to RS, then we will return that. That is the logic. So see, we made prefix sum array and it becomes so easy to do that. If I would have, if I do not make that I have to, I don't know how will I do. I will have to do a brute force approach. I will find the sum of this continuously. Then I have to find the sum of this again. It, there will be loops. by prefix sum approach. You can also do this by continuous sum, which is you can say you can say a subset of prefix continuous sum, which is similarly say you can that I have calculated the prefix sum already. But in continuous sum, you are calculating that prefix sum in the runnings, and you have the total sum in your hand. So you can do either the things. You can do the continuous sum, you can do the prefix. Here, the topic is prefix sum. We'll cover the prefix sum, and we will apply this formula TS minus AI for RS. So for the LS, obviously, it is element where like so here when we go to the one index, LS becomes one. We add this, and what this becomes? We are at the eighth index. Now 8 should be minus from the total sum minus 8, which is here 5. So this is a variable thing. I cannot put a of I here. So that's how you see the mistake. We have to have one more variable here, which takes account of the ongoing sum. So this one we have 8, 6, 5. We have that's the that's why we can find it. See that 3 plus 6, 18, 6, 20, 5, 11, 11 and 6, 17, 17 and 3, 20, yeah. So, so yeah, this formula is right, this formula is right. Yeah, I'm on with confusion. But that's how we make the confusion into clarity. Just to try run and see where you live. So let's implement this on LeetCode by making this prefix something and apply this formula, which is absolutely right when this to the equal will be that. See that I have made a prefix array here. I have initiated the prefix, declared and initiated the prefix array, and build it by this formula that I told you previous slides. After doing that, I have found the TS. So why TS is the end element of the prefix array? Because the end element of the prefix array has a prefix. We erase it. Find it. We'll return minus LS0 as a RS0. I'll tell you why. And I is equal starting line. Now I while I should be less than equal to we don't have I greater than 0 ls. Why I put here I greater than 0 is basically this. This thing is I think not the most. This thing I will explain. The things I think let's tell you this is if I greater than this I minus b I plus. So when I on the current element, the left sum is the previous prefix array. Prefix array has all elements which is storing the sum up to their index. So if I want to calculate the left sum, then I have to calculate, then I have to point out to the my previous element, so that I can find the left sum. That's why I written here pi minus 1, which is previous element of the current element. But I cannot do it as I is equal to 0 because at I is equal to 0 we do not have any previous element. So if we do not have any previous element, it will show me error x out of 1 I 0 minus 1. That's why RS is equal to TS minus PI, which is TS minus PI. I showed you as a current. We have to subtract the current element. Then we compare this. The left sum is equal to right sum. The, then you can use the index and take the loop with the answer. Otherwise, if you don't find the answer, then we give you the minus. This is the implementation of LeetCode, which you can see that it's I'm not able to live code in this session because there is some problem. I will do live coding upcoming sessions. Don't worry about it. Let's move to the next question. We have covered only this part, which is first point, and the theory I do. So this video is becoming too long. I am splitting this video into parts. The next part will come in which all these three questions will be there. All these questions will be there. I want to cover this in this video, but the videos will not so I have to do other things also to my DBMS series was there and my SQL series is also there. So I have to keep up with that also. So I will cover this, but in the second part. So stay tuned. You have understood the prefix sum concept. Now we will deep dive into the next video. Next video will be full of problem solving, nothing else. So if you're watching up to this mark and you are hearing this update, thank you so much for watching. Please hit the like button, share this video with friends and students who want to. Please hit the subscribe button for good updates. Thank you.